Alrighty, folks, welcome back to Michelle's version of calculus, and today we have Unit 1.9, multiple representations of limits. Now, this this unit is kind of a repeat of everything else that's been discussed in previous videos, but we're still going to go ahead and go about it. Of course, we should know by now that limits can be represented in multiple ways. And so here we have a lovely little College Board question that kind of shows that. So of course, the first way it's represented is with our piecewise, second is with a table, and thirdly is with a graph. All right, the question is, if h is a piecewise linear function such that lim of h of x as x approaches 3 does not exist, let's highlight this right here, does not exist, which the following could represent the function h? Alrighty. Alright, once again, I am aware that the correct answer is already viewed, but we're going to go ahead and talk through why each one is not right. Alright, so let's start with the easiest one. Because 3 is a graph, it's most easily to see and visualize. So where they said as x approaches 3, and right here, as x approaches 3, as we can see, there is a jump between these 2 points, and as x approaches as the line over here from the left approaches 3, we can see that the limit is 7. However, as the line approaches 3 from the right, the value is 4. So, and there's a jump discontinuity also. So we actually know that a lim does not exist for 3, which is perfect because at 3 they are looking for a limit that does not exist. So we know that 3 is definitely an option. Alrighty, let's change colors. Now let's go to 2. Alrighty, so 2 over here, it says which of the following could represent a function of h. So we want, alright, cut that out. Alright, so now we are at number 2. As we can see here with number 2, let's draw. Once again, let's go ahead and highlight this little puppy over here. This is our kind of little center moment that we're going to highlight. All right, cool. So, all right, so from the right, we can see, or I apologize, from the left, my guys. From the left, you can see that as x approaches 3, that h of x approaches 7. All right, it approaches 7. However, when you come in from the right, over here, as this one approaches 3, we notice that it actually approaches 4. And so over here, you can actually perfectly see because of this that there also is a jump discontinuity. And the limits are not equal, meaning that, or the limits from the left and the right are not equal, meaning that the limit, once again, does not exist at or as x approaches 3. And crazy enough, these are representing the exact same thing. This is basically just a table for the graph. Alrighty, and now we're going to break apart into choice 1. Alright, so over here, as you can see, we have our little piecewise, and let me kind of try and zoom in over here. Let's find a different color. Let's go green. Alright, so 2x plus 1 over here, and it says for x less than 3. This is basically the same thing as saying as it's coming from the left. And x greater than 3, this is basically the same as saying when it comes from the right. So we're going to take 3 in, and we're going to plug that in over here. So 2 times 3 is 6, plus 1, that will give you 7. All right, so as it approaches from the left, the limit is 7. And 10 minus 3, let's just put a little 3 here. 10 minus 3, so as the right is also 7. And because these limits actually do equal each other, 7 equals 7, and the limit from the left and the right equal each other, that means a limit here does exist. Means that this is wrong because it's asking as x approaches 3 for it to not exist. And it's easy for people to say that because it's undefined here, at x equals 3 is undefined. But basically when it's saying it's undefined, it means that there is just no functional point or value at x equals 3. Okay, but there is still a limit that exists. Alrighty, so this is why our answer is going to be D. Yay! Perfect. Alright. Okay, and now we have absolute values. And I mean, with absolute values, I may or may not solve this one, but the important thing you really need to understand is that when you have this absolute value, you kind of want to break it up into these two separate things, kind of like a piecewise, all right? So we're going to have the top part being the positive x minus 2, and then the bottom being the negative x minus 2. And you're going to say that, and this, bracket, and this is for when x is greater than or equal to 2, and this one, of course, is for x that's less than 2. And this is very similar, of course, to having it basically saying that this positive x minus 2 basically is the same as approaching from the right, and then, let me change that color because I've been doing red, from the right, and this one kind of coming from the left. It's basically like that. So when you're asking you to find the limit, when it's asking you to find the limit, like in this question over here, the limit of 2, or the limit as x approaches 2 of said function, the little negative here means that it wants you to do it from the left. So you would use this bottom equation here for the top. So, all right, let me go ahead and just solve it so it makes sense for you. All right, so I'm going to go ahead and draw this out for you guys so it makes a bit more sense. So, of course, we'll have negative x minus 2 because it is approaching, it's asking for when it approaches from the left. And I will have this over x minus 2. And basically, because of it's the x minus 2's over x minus 2's, it's like dividing over itself. And so that'll just give you 1, but there's negative over here, so this will actually just give you negative 1. So your limit, let's write this full out, guys. Don't forget. In fact, I actually forgot. All right, so the limit as x approaches 2 from the left is negative 1, and that will be your final answer. All right, that's it for 1.9. Thank you.